In this video, I'll be solving the first homework problem in steel design. And this is basically just a RISA review or a little tutorial for those of you who haven't used RISA very much. We've got three different frames here. We have a moment frame, a braced frame where both stories are braced, and this is kind of a braced frame. One story is braced, but because this one isn't braced at the base here, that's what's known as a soft story. And what we're going to do is put these into RISA and solve for the lateral deflection. Okay, so I'm going to go ahead and start up RISA here. Now, the first thing you want to do is to kind of set the grid up to match the problem. So we'll go ahead and close this one out here. And this button here, modified the grid, that's what you use to do it. So I believe so the frame is 18 feet wide and the stories are 12 feet. So when I put that into here, it'll be 18 feet in the X direction, and I've got two stories at 12 feet. Click OK, and now there's the grid that'll allow me to put the problem in. Now we just kind of work our way across these buttons up here. And so the first thing is we'll put some members in. And I like to use section set, so let me show you how to do that. So we're going to, well, first of all, we're going to assign a section set here. And if we come back over here to the data entry panel, click on section sets, and I'll add a new one, and we'll call this the frame section set. The shape that was given, the HSS, those are tube type sections. So I'm going to scroll down here until I get to the 6x6s, the HSS 6x6, and that last number, that's the thickness of the tube. That is in 1/16 of an inch. So the 6x6 by 3/16 is this one here. Click OK on that. Alright, so now my frame section set uses that 6x6 by 3/16. So I'll get out of this now and then go back to bring up the member thing. And so we're going to assign a section set, and we pick the frame section set, and then I'm going to apply it. Now by default, RISA assumes moment connections, so I can go ahead and just draw everything in here, and all the members are the same size. Now I need to pick it up here, so you can right click or you can hit the escape key and then draw another one in across there. Okay, now I'm done with that, so I kind of work my way across. I don't draw in any shells or walls. We do have to put the boundary conditions in, or the reactions. It's a fixed, so I click on fixed, I apply that, draw a box around the bottom. Now both of those are fixed. Now let's put the loads on there. It's a load, it's in the X direction, and the magnitude is 4 kip. Notice the units are here off to the side if you're not sure what units you're using. Now one thing you need to note, this is going into basic load case 1. So I'm going to go ahead and apply that. And again, you can draw a box there. So I've got the two 4 kip loads. Now in the full version of RISA, you have to define load combinations. It's kind of assuming that you're using LRFD or load combinations in ASD. So you click on load combinations here. There's nothing there. So I'm going to put in a load combination. I like to call it the default. You can call it whatever you want, but I like to call it that. And basically what you have to do is BLC, that's the basic load case. And if you come over here, you can click in the data entry panel, you can click on the basic load case, and you can see those two joint loads I had there are in the first basic load case. So I want to put the basic load case of 1, and we're not going to factor that. We'll assume that those are already factored, so I put a 1 there. That's the factor. Now everything should be set up. There it is. And so now we solve it. And we're going to solve that load combination I just defined. It's always kind of good, first step to kind of look at your results to make sure they look reasonable. A good way to do that is to look at the deflected shape. In order to look at the deflected shape, I need to look at the plot options. And that's this button right here. I think that's supposed to be like a little monitor there with a frame showing in it. Or you can click F2, as you can see there. So I click on that button, I click on the deflection diagram, we're going to pick a load combination, and it automatically picks the first one, and we apply it. This frame really isn't very stiff, and so we're going to get a lot of deflection. So to make this a little more reasonable, I'm going to change the magnification factor here to 5 and then apply that. This looks pretty reasonable. You've got double curvature of the columns. We talk about that in structural mechanics. And the beams are also in double curvature. That looks like a pretty typical deflected shape for a lateral load. So it looks like I've set things up correctly for the moment frame. Next, we can look at what the actual deflections are. So here we go, and you can see node 5 and node 4 over here. So I've got about 3.5 inches at the first story, 7 inches at the top story, and that, depending on what you're doing, that may be too much. If you've got a masonry wall on the exterior of the building, that's 7 inches at the top, may be too much deflection. It may crack that wall. Okay, but that's what the deflection is. Okay, so now let's go to the braced frame, and let me turn off the deflected shape here. Okay, so we're back to the original model here. Now, the first thing I need to do is, for the brace frame, we're not going to use moment connections, so I need to change these from moment connections to shear connections or pinned connections here. And so the way we do that is I'm going to go under members. First, let's turn the member numbers on. So there's a little M button up here that turns the member numbers on. So the beams are members 3 and members 6. So I come over here to the dialog for the members. I click on that in the data entry panel. And you can see here's member 3, that's a beam. Now in order to change it, you have to go to the advanced option. So I go to advanced, and this release here, the I and J release, that's how you tell it whether or not it's a fixed or a pinned connection. So I'm going to click on this, and I'm changing the model, so I say yes. And now I want this pinned at both ends, and then I click OK. And I'm going to do the same thing for member 6. Pinned at both ends. And you can also just type in pin it there. Now, here's what happens. In RISA, that circle there means that there's no moment at the connection. So now I need to put in the cross bracing. Let's open up the new member dialog. And again, it's that frame section set. Now here, I'm going to go ahead from the start, under these release codes here, I'm going to go ahead and pin it at both ends to begin with. So I apply it. And let's go ahead and brace it. That. And brace it again like that. And again, you can see the circles at the ends on the diagonals. That means it's a shear connection. No moment at the end. Now everything else should be the same. We can go ahead and solve it. So we solve it. And if I want to look at the deflections, you can see much less. I mean, essentially 2 orders of magnitude less. At node 4, I've got 7/100ths of an inch versus 7 inches before. So you can see a braced frame is much stiffer. It reduces the deflections by quite a bit. Obviously you have extra members in there, but you don't have to use moment connections, and so it's not necessarily that much more expensive and much more stiff. If I look at the deflected shape, so I go to the deflection diagram, load combination. Now if I apply that, I probably won't even be able to see it. And in this case, I'm probably going to have to turn it up. Let's turn it up to 40. Apply it, and you can see even at 40 it's not moving a whole lot. So brace frame, you can essentially assume there's almost no displacement there. Much better job controlling displacements. Let's do that soft story frame. And so here's the member I need to take out, and I just like to I think there's some tools like this here, you can exit with that. But I just like to go into the dialog for the members and just get rid of it. So if you go to members, member 7, F4 is what you hit. So if I hit F4 here, it will delete that entire line. Of course, that's going to change the model, so RISA asked me about that. So now that member's gone, and now I can solve it. And let's turn on the deflected shape again. And again, it's huge. You can see there's not a whole lot of, as far as the total deflection from the top to bottom of the second story, there's not a whole lot because you've got that cross bracing in there. But down here in the soft story, you do get a lot of deflection, and that then causes the columns to bend fairly substantially up on the upper level. And so again, I'll turn this down to a much more reasonable deflected shape. So that's kind of what it would look like. And you can also, within these plot options, you can look at the moment diagram. So if I go to members here, click on the moment diagram, and we'll go ahead and put the magnitudes on there. We apply that. And there's your moment diagram, and you can see this looks about right. You've got, I guess, negative moment here. If I look at this, and of course RISA is backwards, so it's kind of showing this as positive moment. And then I've got an inflection point right about there where the moment goes through 0, and then the rest of the way here, that should be positive moment, but RISA is plotting it as negative. RISA uses the opposite convention that we teach you typically here at UW-Platteville. Turn off the deflected shape. So here's the moment diagram, and you don't get any moment in the beam or the diagonal because those they're just pinned at the ends, and so they're like 2 force members. You can't get any moment in them. So that's how you solve it. So now hopefully that will refresh your memory, or if you haven't used RISA a whole lot, hopefully you've learned how to use it. So that's how to do the homework. I'm going to go ahead and cancel out of this. Of course, you'll need to print up the deflected shapes of all three of those frames. And then if you come into joint deflections, you can just read off, again, it's node 5 and node 4. Those are the deflections we're looking at. You can just write those onto the printout and just turn those in for Thursday.